Hello, this is Daniel Pardock, and I'll be talking about an article by Jax, Rosenbaum, and Vaughn entitled Extending Fitz's Law to Manual Obstacle Avoidance. So, a bit of an introduction. Fitz's law predicts the time required to rapidly move to a target area is determined by the distance to the target along with the width of the target. This law is most often used to model the act of pointing, either physically or with a device such as a mouse on a screen, which is what most of us are used to. So the study that I looked at for this presentation worked to determine if this law could be extended to predict movement times for a curved line rather than a straight line, and also avoiding obstacles along the way. So one of the things to think about in this presentation and in this case study was, what if a direct movement is not possible? What if you can't get directly to that point from your starting point if something's in the way? So the presence of an obstacle increases the distance to get from one point to another, but it doesn't do anything to the actual distance between the targets. So this study took a look at that and wondered if Fitz's law would still apply. So once again, the distance between the 2 points stays the same, but because you have to move around the obstacle, you're increasing the required distance. So the study took place at Penn State. It asked several volunteers to perform reaching movements between targets. So there were two different ways to do it, as you can see from the screenshot below. At the bottom of this slide, sometimes there was an obstacle in the way, other times there was not. And they left it completely up to the participants to choose their own paths around the obstacle when it was there. Half the time it was, and half the time it wasn't. One way to keep people as honest, I guess is a good way to put it, to work quickly and give them the quickest time possible would be that they gave everybody a score. So the score was a total time multiplied by 1 plus the number of collisions that they had with the obstacle if they couldn't get around it. So they had the participants continue that over and over, and they were encouraged to get a lower score each time. So that, of course, fed into people's a little bit more competitive nature in order to get the best score. So the first analysis that they did asked a couple questions. The first question was, how did Fitz's law do without an obstacle? And as they expected, Fitz's law acted as it should, and it accounted for a large proportion of the movement time variance. So that wasn't anything out of the ordinary. So when Fitz's law was applied with an obstacle present, there was much less proportion of the variance. So the conclusion that the scientists were able to draw on that one was that Fitz's law accounted for significantly more movement time variance in the obstacle absent condition than in the obstacle present condition. Their second analysis, they wanted to take a look at if movement times could be predicted just by taking Fitz's law and using a simple elaboration on it. And what they came up with was that by defining a measure of obstacle intrusion, as they put it, and adding it along with Fitz's law, a much larger proportion of variance in movement times could be accounted for. So along with that, here's the equation that they came up with for doing that. The movement times did very well, as it says here, at accounting for along with that extension of Fitz's law. And they also went so far as to say this success fit in with the spirit of Fitz's law. A couple of conclusions that they came up with for this one was that the study confirms that it would be more useful to predict movement times from the layout of the study environment rather than compiling results after the movements have been completed, and also that obstacles don't have to get in the way of relying on Fitz's law for predicting times of complex obstacle avoiding movements. Okay, references on this obviously were the textbook, and then here is the information on the article itself. Going back to the conclusions that were drawn, on this, were that Fitz's law worked perfectly on this, and that by coming up with an equation, they were able to figure out that they could use Fitz's law along with that equation to offset any obstacles that might come into play in that study. Thank you.